My name is Chris Ritson. I'm based here in the UK. A little bit about myself. My career in project risk began back in 2006, and I've worked on UK highways, rail, major civil engineering, mega projects such as Crossrail, High Speed 2 in London. And we're going to be looking at why I joined Safran, actually, I suppose, in one way or another. So just in case anyone suddenly loses their internet connection, what I'm actually going to do is I'm going to start by giving you some quick sort of 7 discoveries that I made on my last project before I joined Safran. Now, back at that time, I was comparing available software that could actually address our primary need, which was to find a way of integrating our costs and our schedule risk analyses together, because we actually knew that interfacing them from 2 different sources was actually wrong, but we'll cover a bit more on this later. So very quickly then, the 7 discoveries that I made. Firstly, that Safran Risk is a database. It simplifies the creation of multiple scenarios or trending your outputs over time. The second thing was that the user interface is actually designed to follow typical workflow of creating a risk model. Third thing was that there's actually a variety of methods available to you when you're looking to integrate your cost and your schedule risk into the same Monte Carlo simulation. Fourth, not only was the risk mapping exercise made simpler, it also did it through visualization and feedback. So as you're creating and linking the uncertainties and risk activities, you can sort of sense what's going on. 5, the sensitivity analysis automates the discovery of how much each risk is actually contributing to the output of the Monte Carlo model. 6, something extremely clever that I wasn't expecting to find was the ability to blend pre and post mitigated scenarios together into the same simulation. And 7, there's a feature that focuses on critical or near critical paths towards specified milestones. And that's particularly useful if you're engaged in what's called rolling wave planning. So now that I've shared my overview of some of the significant and noteworthy features, I'm actually going to explain something a bit deeper and more significant about how the software developers have actually woven these things together into something that is greater than the sum of its parts. But before I elaborate, I first have to just ensure that everyone that's on this call today is actually aware of what Safran Risk is actually designed to do. So essentially, it's used to combine different versions of a project schedule, cost, risk profile into a predictive model, which can then be rerun and compared with alternative scenarios. And this can be done for a fraction of the upfront investment, potentially saving millions in costs and significant time savings. So for this, we need a basic understanding in how these models are created. So let's start with an in a nutshell description of the critical path methodology, so CPM, and we'll quickly build up from there. So a project consists of tasks and activities, each with an estimated duration. The tasks have a logic saying when they can start, e.g. not until another one has often finished. And we tend to not put any dates into the model except for maybe the start date, because what we're then doing is allowing the CPM to calculate the rest of the dates for successive tasks, including the project milestones and overall completion date. Now, this is a very simplistic description. It doesn't include anything to do with costs, resources, constraints, float, resource leveling, and calendars. All of these things mean a lot to schedulers in particular. But the key here in this sort of description is that we're only actually entering the logic that reflects the reality of the project, and then we're leaving the scheduling and date calculation up to the software itself. Now, the problem with the CPM method is we don't really know anything about the chance of achieving the milestone dates, and if the deterministic plan is even remotely credible, or if the critical path is more likely to follow an alternative sequence of events. So quantitative risk analysis, QRA, can help us to answer this and some other questions. So if instead we're using a scheduling uncertainty approach, we can express a range of estimates instead of a single point estimate. So 10 days might be the most likely, but perhaps the team will achieve the same in 7 days or anywhere up to 17 days. And then when we do this for 1 or more tasks, the project finish date becomes a probabilistic range as well. So schedule risk analysis is about working out what these ranges are and discovering what is most responsible for causing delay to the various activities, milestones, and ultimately the completion date. So So with the input ranges decided for each of the activities within our schedule, we can now watch a simple animation for how the Monte Carlo sampling method will randomly select hypothetical values for each activity that supersede the deterministic or the planned duration that you've put in there. And we can reasonably expect for most of the iterations to fall around the most likely part of the range, with a few iterations occasionally being sampled near the extremes of that range. And this process will continue for as many iterations as you have instructed. Typically anywhere from 1,000 to 10,000 random iterations would be considered quite normal. So we've seen how there might be some natural variation in how long a task may take to complete, and we typically refer to this as estimating uncertainty. However, uncertainty ranges can be further influenced by hypothetical events that may or may not occur. So we call these risk events, and they have a probability of occurring and stressing the schedule model beyond the parameters previously defined from your risk register. So for those that are unaware, let's just very quickly consider the wider factors in the sort of the process, how you build that model. And you'd start by importing or creating a baseline schedule or potentially cost, either from P6 or Microsoft project, or you could create one directly within Safran itself because it's got a fully mature scheduling engine from 25 plus years of experience in Norwegian oil and gas industry. But it's optional to do the cost model. You don't have to, and it's optional to do the schedule. You could do just a cost risk analysis if you really wanted. Now, the next step is you validating the integrity of that model, that underlying model, the logic that's there, and that's a significant step. But once you get past that, you then start to map the risks and the uncertainties as have been identified and assessed by your team of subject matter experts who are typically owning risks on the risk register, and you're now able to run that Monte Carlo simulation. So you do that, and you'd review the results against a particular confidence value. It might be P50 or P80 or whatever it might be that your company particularly sponsors, and you'll look at the drivers of what's driving that particular p-value, and you'd see that against a particular objective or milestone. Now what will happen here is you begin to spot some issues with that output, because some things will stick out as not being quite right, and it is, after all, a bit of a garbage in, garbage out system. So you'll find yourself running through steps 2, 3 and 4 again and again from experience. Now what you'll do is you'll iteratively refine that model until you're finally in a position to communicate the output and the result to the stakeholders, and they'll use their experience to challenge your outputs and your results. However, this process is often done under a time constraint. In my experience, it's often left till last before the submission of a deadline or something, and the risk teams that I've been involved in, they seldom get the access that we need to the key team members. They're just either too busy or they don't see this as being a priority. Now, ideally, we risk professionals would be able to provide additional support to the decision-making leadership by giving them some actual alternatives to discuss, to kind of consider. So we'd also like to provide some recommendations, but to do this, providing them with more meaningful choices is only really going to happen when the full cognitive diversity of the entire team is able to collaborate and respond to the process outputs as well as the inputs. And that's exactly what I believe Safran Risk will help you to do. So in that previous slide, I've described that there's a tension that often exists between the widely understood academic benefits and then there's the reality, trying to implement what is seen as a time-intensive process. It's often paid lip service to, and therefore it's unable to reach its full potential. So some of you may recognize the situation in that cartoon where your efforts are basically ignored and you're wondering why you bother. So how can Safran Risk help with that? Well, let's bring it back to why I chose Safran Risk. So I saw that it enables increased collaboration in building your risk models together as a team. Now this is absolutely key, massively foundational aspect for me, because when you do this, you're ensuring the highest possible quality of the model inputs, and by definition, you're increasing the quality of the model output. And this is already really excellent news, but perhaps more importantly, people becoming more trusting and accepting of those outputs because they were involved in the creation. And actually what you're doing is you're creating a safer space for them to start asking hypothetical questions because they own it. They can say, well, when I said this value, what if it was that value? Or what if it was a different value? So you can start testing some theories and discovering some insights together. And then once you have a key sort of range of options and recommendations from going through this process, you can actually then focus the decision maker's attention on just those uncertainties that actually matter and the choices that you've discovered. Now, I mentioned that the collaborative approach is key, but how does Safran actually achieve that? So, well, it actually starts through having intuitive design, and then you couple that with lots of feedback. Now, this approach allows participating team members to experience the benefits firsthand for themselves, rather than contributing to a box ticking exercise that doesn't feel like it's connected to what they actually do on a day-to-day basis. So that means that over time they'll grow more curious and they'll want to stretch towards the more advanced modeling techniques as they begin to own the model a bit more and go, I wish it could do this. And you go, well, it can actually.